Shear force and bending moment diagrams. Let's take a look at this example. Draw the shear force and moment diagrams for the beam and determine the shear and moment in the beam as functions of x, where x is larger than 4 feet but smaller than 10 feet. First, we will set up our positive axes. Next, we will draw the free body diagram of the entire beam. We will then use this, as well as our equilibrium equations, to find the support reactions at A and B. Solving for the summation of forces in the y direction, we find that AY and BY are both 450 pounds. Now we can draw the free body diagram cut at X. Remember our standard convention for shear force and moment. Using this and our equilibrium equations, we get the shear force as 1050 minus 150x and our moment as negative 75x squared plus 1050x minus 3200. Lastly, we can create our shear force and bending moment diagrams. Starting with the shear force, we have no shear force until point A. The force AY pushes the diagram up by 450. The distributed load will decrease the diagram linearly. The distributed force is 900 pounds, meaning the diagram will go down 900 pounds. Starting at 450, if we go down 900, we end up at negative 450. By will push the diagram back to equilibrium, which is at 0. For the bending moment diagram, we start with our externally applied counterclockwise moment, which produces a negative internal moment. This is constant until the distributed load. The first area is 675 feet above zero. Thus, it increases parabolically to our maximum 475 and go down 675 due to the negative second area. From negative 200, the diagram will go back to zero from the externally applied 200 clockwise moment, which produces a positive internal moment. Using the procedure we learned in the previous video, we were able to find the shear force and moment as functions of x, as well as construct the shear force and bending moment diagram.